Okay, now that we've talked a little bit about exponential equations, we're going to look at some solving techniques. So first thing we need to introduce is this guy called a logarithmic function. These guys are inverses. That means that as this graph goes up, this graph would be going down, right? Every point is reversed because they're inverses. Now what that provides is this relationship that lets us use a logarithm to solve an exponential equation. This is what they look like. That's an exponential function. That's a logarithmic function. And you can see some key pieces right here. There's a b and a b. There's an x and an x. This one has the word log in it. And that's basically the converting part of it. So log, here's the equation. This is what it looks like. B and x are positive real numbers. B cannot equal 1. And it's read the log base b of x. Now here's the reason I stress that, because I will say things like that and you need to make sure that you understand what I'm talking about. For example, if this was the function I was talking about, I would say log base 3 of x. And I expect you, when you return telling me the log, that you can say it the exact same way. This one right here, notice there's no little number right there. There's no base. When that happens, the base is 10. It's kind of like a power without a power written there. It's a 1. This is what the log base is. It's log base 10 of x. It's called the common log. And then here's our natural guy again, right? Remember, E was that special guy that got his own equation, exponential equation involving this E. Well, here's the counterpart to that, the inverse of that. And it's read the natural log of x. This is an L, not an I. You can say the natural log of x, or usually what it said is ln of x. And then I realized that when I said it slow, it sounded like I was saying ln of x. So that's how you'll pronounce that one. All right, let's explore, kind of look at this, maybe pause the video for a minute and go through, see if you can figure out how I turn this into this, and then reversing it, how I turn this log into this exponential. See if you can see the relationship between those. So hopefully you paused and tried it. Maybe not, you just waited for me to start talking again. That's okay. You can see the common pieces, right? There's a 2 here. It's the base of the exponent. And then over here under the log, that's the base of the log. Log base 2 of 16, right? And then notice that this 4 now, he was on the left side of the equal sign, and now all of a sudden he's on the other side of the equal sign. And same thing with the 16. Now all of a sudden the 16, instead of being on the right side, he's switched sides and come over here with the log. So this is the converting that goes on. You take the base and it becomes the base. Easy. Then you swap these two. -2 goes on the other side that it was on. 1/9 comes on this side. And you write the word log. So notice how these two swapped. And then vice versa, when you go from log to exponential, the base becomes the base, and these guys swap places. Notice now 1/2 is on the left side, that's a power, and 2 is on the right side. So 2 is inside the log, now all of a sudden it's by itself. 1/2 was by itself, now all of a sudden it's the power. So this one, you take the base, 8, and swap places. So now it's 8 to the 2 power equals 64. Here's a formula for it. To go from exponential form to log form, which is the key piece of today. If you have some number, a base, raised to the x power, and it equals something else, then it's a simple transition. The base here is the little guy under the log. Sorry, you start with writing the word log. Duh. X and y swap places. So now y is on the left side, or the side with the base, when over here it was without a base. Now x is on the other side without a base. So base B is the little guy under the log, and then you switch the other two pieces. Okay, rewrite each one in log form. Write the word log. This is the base, so I'm going to write a little little 5 down there. And then 25 is alone, so he goes into the log, and 2 goes out of the log. And that's it. Okay, this one, write the word log. Base is 10, so I write a little 10. 0.1 is outside. Now it goes inside the log, and the -1 goes outside. Okay, even when there's fractions involved, it doesn't matter. You still just write the word log. The base becomes the little guy, and then the 4 and the 2/3 swap sides. 4 is alone, now it goes inside. 2/3 was up in the power, now it gets to be alone. Then there's this guy, E. E is the easiest one to switch because as soon as you see E, you're going to write ln. And then you swap these two. 20 now goes with the ln, 3 goes by itself. And that's swapping from exponential to log form. If you want to go the other way, it's just as easy. One of the tricks that I've been shown before was using a loop. B to the y equals x. B to the y equals x. So the base, this is the power, and this is the other. So 2 to the 4 equals 16. 2 to the 4 equals 16. 4 to the 0 equals 1. 10, because there's no log written, we assume it to be a 10. 10 to the second power equals 100. Okay, oh, there's nothing here. That's okay. ln and e go directly together. If you see ln, you write e, and then you swap the other two numbers. Okay. Oh, these ones are missing part of it. We'll just ignore those. Sorry, just see me freak out. Hold, pause, I said, in my brain. All right, some more examples. Rewrite each in exponential form. Okay, loop. 6 to the second power equals 36. You know it's going to be exponential, so it's got to have a base and an exponent and an equals to. Okay, 289 to the 17th power, 289 to the 1/2 power equals 17. This one says 14 to the -2 power equals 196. 1 over 196. Okay, 3 to the 4th power equals 81. Okay, let's go the other way now. Can't pick a color. Okay, rewrite in log form. Oopsie. Starts with, write the word log. Okay, the base here becomes the base on the log, little guy. These guys swap places. So 8 goes in the log, 1/2 gets to be alone. Okay, write the word log. The base gets put under the log. These two swap places. 144 goes in, 2 comes out. Write the word log. Find the base. These two swap places. 1 over 81 goes into the log, -2 goes out. Write the word log. Find the base. Write it down under. These guys swap places. 1 over 144 goes in, 2 comes out. Easy as that. So now, why do we use that? Well, it helps us solve these exponential equations. The problem with exponential equations is that this variable is up in the power. How can we make a statement that says x equals when x is stuck up in the power? So we're going to use logs as one way of helping us solve this. Your first step is to get that exponential, that exponent below. So I need 2 to the x to be by itself. Solving just like regular things, add the 5, then you end up with 2x, 2 to the x, sorry, equals 11. Now, here's where logs come into play. If I convert this to logs, write the word log, here's my base, goes underneath, these two swap places. 11 goes inside the log, x comes out of the log. So what I have right now is that x equals the log base 2 of 11. And from that point, you can pop it into your calculator. Boop, boop, boop. Calculator says, and it will give you that value, and that's being solved for x. So if we are rounding that to 2 places, that's about 3.46. And that's been solved for x. Okay, this next one, we're going to apply this converting formula. Anytime you see E or you see ln, they automatically just replace each other. And then the other two things swap places. E and ln are the easiest because you don't have to think about what the base is and does the base go here, what number goes here. It's E turns into ln and then you swap the other two pieces. So right now, this is what I've got. I prefer my variables on the left. 2 times x equals ln of 5. Okay, get rid of that 2. So it says x equals ln of 5 divided by 2. Okay, boop, boop, boop. Calculator says about 0.804. So it'll just be, let's go with 0.8. Okay, now on your calculators and on Desmos, there's two, both have a way of using the logs. So on your calculator, if you do a math menu, and go down, down, down towards the bottom, and there's one that says log base. If you choose that, it pops up the word log, and this little box down below, and this little box up above, so that you can plug in a base underneath, and then the stuff that's up in the top. There's also an LN button. You just hit LN and plug in your stuff, and that's it. On Desmos, you have to go to, let me show you, hold on. Okay, if you are using Desmos, click on the little thing and hit the keyboard. Over here to the right, it says Functions. And then under Miscellaneous is where your log. And then there's a regular log for the common log, or there's a log with a little baby A down here. That's the one you'll use if it's a different base. You can hit LN, or you can just type the letters LN and it will know. Or you can just type the letters LOG if your base is 10. This is the one that you would have end up using though. So log base, let's say 2 of 24. Whoops. 4.58. Okay, so Desmos will do it for you as well. Okay, solving some of these other ones. Now, it's nice when the exponent is already alone. There's nothing around. The 16 goes with the exponent. It's part of the base. But as soon as it's in this form, you can just convert. Write the word log, find the base, write it below, swap sides. Okay, plugging that into a calculator. Boop, boop, boop. Or to Desmos. X is about 0.79 if we're rounding to 2 decimal places. Okay, next one.